So, welcome everyone to our 11th week of the class. It's quite a journey through this whole class so far. Today we have our first speaker, Gabriel René, who I know for a while. We had a couple of really interesting conversations. I'm so happy that he's joining us today for the class. He's the CEO and founder of the company Verses, and he's the executive director of the Spatial Web Foundation. And he also started the IEEE Spatial Web group that's looking into standardizing protocols and infrastructure for the spatial web. He does put a lot of effort in all of his work, so I'm very happy to hear from him and hear what's the latest and greatest. So, Gabriel, welcome to the class.
It's great to be here. Thank you, Valentin. Hello, everybody. Nice to meet you.
Want to take this as a conversation, or?
Well, how much time do we have total today?
We have 45 minutes time.
Why don't I walk through a deck for about 30 minutes, just kind of frame it, and then we can have about a 15-minute dialogue about it, the implications of that relative to the topic. So more about giving an overview of the spatial web narrative, kind of what it's attempting to tackle different than, say, other narratives, or how it synthesizes them. And then we could discuss more the implications relative to, let's say, the future of digital assets and commerce in X number of virtual and or real worlds. How does that sound?
Perfect. Let's do it.
Excellent. Okay. Can everyone see my screen all right? Yeah.
Yes.
Well, hello, everybody. My name's Gabriel René. I'm, as Valentin was so kind to say, I'm the CEO of a company called Verses. It was formed in 2018. I have a background in cybernetics. I worked in advanced R&D for the last 30 years at the intersection of AI, Internet of Things, augmented and virtual reality, robotics, and network architectures. Also an author, wrote a book that came out in 2019 called The Spatial Web, How Web 3.0 Will Connect Humans, Machines, and AI to Transform the World, with my co-founder, Dan Mapes. You can find that on Amazon today. And so I want to talk to you about this idea of the spatial web, what Deloitte has described as the next era of computing, and how and why it's an attempt to sort of synthesize these various different approaches around emerging technologies into a single narrative upon which we can have a shared understanding of, and upon which we can actually architect interoperable solutions that enable things like commerce between virtual and real worlds, between the machine and the human world, and sort of even across virtual environments of all kinds. So over the past 10 years, we've had this sort of buzzword salad of terminology. From more traditional terms like robotics, we have all, the exploration of things like augmented reality and digital twins and, smart contracts and blockchain and 5G and crypto and now Internet of Things and AI and the rest. And the question is, like, how do we make sense of the relationships between these various concepts and terms? One way to think about this is through the sort of major computing trends. And so if you look at this through the lens of four major trends, you've got immersive computing, which is sort of XR computing. You've got physical computing, which is IoT devices, sensors, actuators, robotics, autonomous vehicles. You have cognitive computing, which is about machine learning, artificial intelligence. And you have distributed computing, which is more about both distributed data storage, like blockchains, distributed ledgers, data architectures and designs, like moving towards knowledge graphs and various sort of distributed capabilities we've seen in this sort of, I will say, the Web3 space. And then the fact that the actual compute itself is also moving to the edge. But one of the key trends here, the sort of meta trend, is this idea that we're moving computing into the space around us, right? And so the idea of the spatial web is sort of anchored in this idea of not just spatial computing in the sense of XR, but also in the sense of computing in space. And so we can think of the spatial web not as a web or a network of pages, but a network of spaces, both real and virtual spaces, and even conceptual logical spaces and mathematical spaces that are not bound to say 3 dimensions. When we look at this series of concepts of eras, trying to get a handle on what is this current phase, there are several narratives that have emerged largely over the last 10 or 15 years that you can see actually being multiple angles on those same sort of trends around computing. So in one sense, you've got this human 2.0 narrative. We go from Homo sapien to sort of Homo cyberneticus, and this is everything around sort of transhumanism, the integration of humans and AI and devices. You've got this society 5.0 narrative, which is the Japanese have really been the forefront of this. The idea of the sort of intersection of digital capabilities, that buzzword salad of technologies, and how does that tie into things like civil services, government services, well-being capabilities for society at large. You have the Industry 4.0 narrative, which has largely been about cyber physical systems and the automation of those systems in the supply chain, manufacturing, et cetera. And then there's the Web 3.0 narrative, which has been a bit muddled because, in a way, the Web 3 blockchain folks sort of glommed onto one, I think, subset of that data, but more or less the idea of Web 3.0 being, again, this convergence of these technologies into a single sort of network that enables all of them together, sort of the internet of everything, if you will. So the thing that we're mostly concerned with is what is happening with the convergence of these various emerging exponential technologies. And obviously with AI now kind of driving a lot of this, this capability, we're starting to see things like, Moore's law applied to AI since 2012 is not like, a year and a half or 2 years, but like 3.2 or 3 or 4 months. And in the last, 3 or 4 months, it seemed like every 3 or 4 days. So the convergence of exponential technology is creating another layer of exponential outputs. One way to think of this buzzword salad then and the relationships between them is to think of them through this concept of perspectives. So you have this breakdown. This is called integral theory. It's the idea that there are sort of 4 major perspectives. You can look at anything on the individual perspective and the collective perspective, and then both the interior individual or interior collective, or the exterior individual and the exterior collective. And it turns out when we look at those sort of 4 major categories of how people are describing these eras, they actually nicely fit into that. The human 2.0 is about sort of this idea of the intersection of humans, physical human, and the physical capabilities and devices of technology. So you have individual exterior perspective looking into that buzzword salad and saying, hey, it's all about the human 2.0 lens. It's all about transhumanism and sort of where this is going. Largely, the metaverse has sort of come out of this sort of Web 3 or Web 3.0 narrative in its latest incarnation. And that's the same thing, but that's like sort of an individual interior perspective, meaning it's mostly about the experience that one has while interacting with these technologies. When you look at the exterior collective, it's the Industry 4.0 lens. It's all about autonomous systems. How do we get these things to work together in a sort of systems theory sort of approach that has to do with the intersection of many different collective things and operating in the physical or natural world. And then Society 5.0 is really more about those interior collective meaning, values, considerations that everything from social equity to climate to data rights. And so you can see that actually everyone is looking at those same technologies, and you can take any combination of them and just run through the scenario here saying like, what is blockchain? What is the lens that applies to say something like blockchain? You can say, well, human 2.0, it's all about protecting my biological data. And so being able to do that. Web 3.0, it's all about generating NFTs and assets that I can use to, as sort of forms of economic currency. In Industry 4.0, maybe it's about security of digital systems, or cyber physical systems rather. And Society 5.0, maybe it's about the carbon credits, or it's about new identities issued by governments to enable voting, or different sort of social services that are built in. You see, you can also get interesting combinations where you say something to the effect of like a digital twin of my heart that I can see in virtual reality, that I have certain digital rights around who can access that. And so now you have a synthesis of all of them. So the question is, how do we take a more holistic view on these technologies and their relationship, as opposed to this sort of era-based narrative that we're sort of stuck in today? And so if we look at this collectively, it's really about the networking between these emerging technologies. What we want is interoperability and governance of their activities and behaviors. And so this is what the spatial web attempts to do, is to synthesize and say, yes, these are various perspectives that may be based on a technological perspective or based on a sort of industry-specific lens. The spatial web zooms back and says, what we're interested with is the interoperability of these various technologies that enable these various different industrial lenses to apply them in a holistic way that actually enables interoperability and combinatorial benefits across all of them. So one way to sort of think about this is through a more simple timeline, that every 15 years, the technology stack sort of shifts and we go from the PC age to the Web 1.0 age, to the Web 2.0 age, Web 3.0 data logic interface, and that the connections be essentially the networks that are formed of these things, whether we want to look at their applications as being relative to X, Y, and Z is somewhat secondary. What is critical is interoperability. And let's say the ability to share real world understandings and models, if these are going to be spatially computing, meaning cyber physically operating in the world, IoT and robotics, working with AI, working and computing at the edge across distributed systems. So this is the idea that the spatial web attempts to bring into play, to say essentially that what we need is a new sort of cyber physical network that enables that interoperability, the ability to define models that are not just about the definitions of documents, but the definitions of real world activities, and apply those in both a human and machine friendly way. And so what you get out of this is something like the type of autonomic functions that we want to see in smart cities, where AIs are operating vehicles that are able to adapt in real time, that are even able to share various perspectives of something. So in the case of this vehicle at the bottom of the screen, being unable to see this person crossing over here, but the camera can, right? And so it's sort of a blind spot for the turn, but this is an autonomous vehicle. It's not going to be known. But however, if you can start to network perspectives, you can start to do sensor fusion, you can start to create policies that enable sharing of data and perspectives in certain conditions, you get something far more like the autonomic nervous system that applies to the global supply chain, applies to traffic in our cities, applies to our electrical grids, will apply to autonomic economic activities, right? You can see a scenario where there are, swarms of cars on the freeways of the future. And if these cars have the ability to incentivize each other based on the goals of the passengers, maybe the fast lane is something that emerges in real time because you pay the cars to get out of your way. This requires wallets and transactions that can all be, sort of interoperably executed in your real time. But if you start to think of the cities of the future as more like bodies and more like organisms and rather than organizations, you start to see the benefits of the real-time adaptation of networks of devices and applications and users that are all operating in the same way. This also applies to all the sort of ambitions around the metaverse. Whether you're talking about asset IDs or user identification or data authentication, or the ability to have locations in space upon which then you can teleport objects and assets and users between, right? Today, we talk about going to a web page, but you don't go to a web page. Web pages come to you. right? And you go, oh, so go to my webpage, I'll go from this webpage to that webpage. So we have this sort of concept of moving between websites when really we're just loading websites in front of us. The reason that that works is because there are addresses, and those links between them, the hyperlink between page A and page B refers to an address. If you don't have a standardized approach to addresses, spatial locations, and in this case, they cannot be just merely a single string. It needs to define some sort of volumetric range of experience, of course, under which all the permissions, activities, economic design, and the policies and laws and rules will all have to apply. This all has to be articulated. And so the spatial web looks at standardized ways of defining, users, assets, whether these are sort of physical or digital, is just a minor point. We need ways of digitally representing people. Of course, the avatars that may be forms that you take are sort of forms of digital representation of you, but also all of the data related to your medical history, or the digital twin of your body and all of your organs. I'm wearing an Aura ring. This tracks, my sleep, my variable heart rate. It sits inside of an application with that company. I don't have a way of exporting that. I don't have a way of combining it with other data sources. I don't have my own data, whether it's my sort of digital representation of my biological activity or avatars that might represent me. We actually don't have personhood of our representations. So fundamentally, data rights and data ownership will become one of the key defining moments in this whole sort of transition. Obviously, we're going to need digital twins that represent real world objects. This is already happening today across manufacturing, supply chain, etc. The maintenance of an airplane, for those of you who don't know, is mostly a book about this big that goes with the plane. And when someone fixes a part, they go and they update that book. These are not digitized, nor do they represent anything specifically to the physical part. And so you're really left with this sort of, Bible to update data when my Tesla is able to, upload and download information or present it to me on a phone or even send diagnostic information back to the manufacturer. This is what's going to be required for all critical systems. You can imagine this not just for individual sort of objects like planes, but for the entire, something like the electrical grid of the future, or even representations scaling out to entire cities or the entire sort of digital twin of the planet itself. There's also the question when we start talking about X versus, or which reality are we speaking of, augmented or virtual or mixed? What happens when these things interact in different ways? How do they understand each other's sort of locations, physics? When we talk about moving from one space to another, objects or users, what does that mean? These all have to be clearly defined. Cross-domain search. How do I search across different locations, different assets in the so-called metaverse or the Xverse, or in the physical world, inside of a manufacturing facility? Where is this item? Inside of a city? Wouldn't it be great to be able to search for your favorite product by the inventory in the entire city? So you're like, hey, where's that key lime pie? Who has it? The same thing applies for any sort of digital or virtual asset. So we need indexes that enable us to have cross-domain search across multiple different domains in different cases, like an infinite number of layers on a map. Google Maps today, you can see traffic, or you can see Mexican restaurants, or you can see what have you. But maybe you need to be able to see Wi-Fi signals or carbon credits in the region, or who knows. Even the digital thread, the history, the sort of data provenance around objects and activities is going to be fundamental. So having historical records, the sort of digital threads that go through these digital twins that are able to give us the ability to have data lineage is going to be a big part of credentialing and certification and authentication that allows for real-time autonomic transactions to occur, as opposed to everything needing to be sort of authenticated on every time. And so today we have this real challenge where when we think about things like interoperability, it's a total pipe dream, because everyone is doing their own thing in their own way. So whether it's sort of virtual world design, avatar design, whether it's digital twins, whether it's sort of smart city architectures, Microsoft, Google, there's this whole challenge in Toronto where Google is trying to build this new sidewalk labs project with the city. It all fell apart, and this has happened like several times now, because in the end of the day, we don't really want Microsoft cities and Google cities and Apple cities and whatever. You're going to need interoperability. The same thing applies to all virtual spaces if we want to connect them. Then there's the challenges around platform. What is a human interface to the spatial web, which would be sort of an augmented or virtual XR, versus a machine interface to the spatial web, which would be sort of IoT or robotics. And those need to basically be the same, because in almost every other case, you're just strapping a machine to your face. AI will also need to be able to understand these world models and the operating context, both in virtual environments and real world environments like humans do. This is clearly a shortcoming today around pinning everything on large language models, because they lack sort of embodied cognition that would give them the additional layers of understanding in order to operate. And so then there's the digital payments thing, right? We're sort of caught between sort of several eras here, where you've got the traditional banking system, you've got the emergence of digital currencies in the form of cryptocurrencies, which are, sort of largely unregulated or poorly regulated. Now you have this intersection of more traditional, CBDCs and central bank digital currencies that are starting to emerge. But then there's going to need to be something that has nothing to do with the central bank of San Francisco or Berlin or the UK, because it's going to be a completely virtual world that's been set up on some sort of a DAO, of which the governance of that virtual world and its economy will likely not be able to fall under the jurisdiction of some physical real world geopolitical structure. So you're going to need to have the ability to have digital currencies and digital payments that intersect into virtual worlds that are not under the jurisdiction of the so-called geopolitical world of Earth. We've already seen this in gaming environments and game worlds, in some sort of virtual reality sort of shared worlds, MMOs and et cetera. But these are just kind of little toy examples that don't actually interoperate together. So these various fragmented approaches to the human world, machine world, and virtual worlds right now, really there is no path that has been presented to integrate them into a single network. And that's what we want. We want all the verses, right? The universe, the metaverse, the multiverse, the Xverse, or whatever you want to think about this, to work together. This is akin to the challenge we had with documents before. We would like documents to be interoperable. We'd like to be able to network and connect them. We'd like to be able to move between them. Now it moves into the spaces around us. So this is what the Spatial Web Foundation was founded upon, was the idea we need to develop a set of standards for this. We partner with the IEEE. We developed the P2874 working group, Spatial Web Protocol Architecture and Governance. And in that, we define a handful of protocols. One is called the Hyperspatial Transaction Protocol. One's Hyperspatial Modeling Language. And the idea here is to enable a set of standards for identity, because identity today is essentially fragmented and essentially owned by others. And so you have this challenge today where, in the Spatial Web book, we talk about this idea that today, you're the sun, and FANGMA and the large corporations, essentially, they own IDs, they rent you an ID, and they're the earth, they're the center of the universe, right? And so it's basically like a corporate identity-centric approach, is sort of the geocentric theory of identity. What we really want is a heliocentric theory of identity that flips this entire model, right? That where you are the sun, you are at the center of the galaxy, and all other service providers essentially rotate around you, right? They orbit you, you can grant and revoke access. And if you look at the laws around GDPR, even everything that's starting to bubble up around AI, what data it can or cannot have access to, we make the argument in the book that this is somewhat inevitable, that the issues around trying to maintain and control more ever increasing personal data, including what's becoming biometric data, will be unsustainable. Regulations won't allow it. It's going to create the sort of the real flippening here. In addition, we think about the lens of new standards. We take the concept of the web today and we say, well, there's web addresses. There's a way to program information on pages. There's a way to link that data. One big challenge today with the World Wide Web today is that it's essentially stateless. So all the states, all the activities, all the websites you've visited, every interaction has been captured by some company. Google browser has your states, but it's in your Google data set, which is not yours. It's theirs unless you want to extract it and put it somewhere else and very difficult to use. We need the same thing, but for the sort of spatial environments. So we take the notion of the spatial web and we think of the idea of HTML being a markup language for information on pages, which became a very standardized way for marking up that data, making it interoperable. And we extend that to what we call hyperspatial modeling language, or HSML. It's a modeling language for objects and activities and permissions in space. And in fact, it's not limited to 3 dimensions, which we can get into briefly, but in any number of dimensions, a sort of n-dimensional hyperspatial modeling language. It operates over in a multi-scale nested hierarchical domain structure. So you think of these as hyperspatial domains. Today's domains on the webs are largely flat. There isn't very much of a hierarchy. The difference between .uk and .com is arbitrary. But here today, we think about policies and governance and permissions of robots, IoT devices, what holographic or augmented reality content can or cannot be displayed somewhere. Well, there may be a federal law that makes it unable to be displayed at a local level, right? Or it may not be a federal issue, and it's only a local issue. And so you have to have this sort of nested regional structure. At the same time, you need to define categories of sort of conceptual spaces so that the certain types of categories of information may or may not be accessible or presentable or embeddable or connected to people, places, and things in the physical world. Or this also allows you sort of a global index. Like if you think about it today, the World Wide Web has no public index of websites. You go to Google. You go to Bing. Maybe no one goes to Bing, but you get the point. And so then you've got websites that have their own sort of local indexes. Twitter, you can search Twitter on Twitter, you can search Facebook on Facebook, but you can't search those from the other larger indexes. But what we need is essentially an index that is a public index for this data that can still be permissioned and limited and constrained by the rights that you have to access that data, but upon which the activities of machines and AI can be governed as well as interoperable. So you get this idea of spatial domains as sort of volumetric, environments defined, let's say, just geospatially here that you can set the permissions for in the spatial web for who or what is authorized to access content or data, sort of CRUD capabilities, who can write, who can read, and who can write. Whether you're an autonomous vehicle or you're a drone or you're a virtual character or you're a human, and or what the constraints or permissions are around any sort of transaction or interaction. So HSML is, this is more of a conceptual example, but you can think of these as a set of 12 elements. These elements define the identities, the sort of who and what, the activities, the what and how, and the locations, the where and when of various you can describe any class of user, or object, or policy, or activity. This is designed to be a completely comprehensive language for AI and machines to be able to understand any aspect of the human world or human context. And you are able to form a sort of a knowledge graph out of these elements that then help you define what an activity is and who can perform it under what conditions, in what space, in what domain, at what time, in what reality even. And the requirement that this activity, which you can see over here on the right, which is performed by an actor or a user, which applies to a particular asset, each of these all having spatial web IDs. You can notice here that the asset exists in a space, exists at a time. The activity occurs in a space, occurs at a time. A user exists in a space and time. That space and time, those parameters, helping to set up a sort of causal structure that then determines whether or not the activity can be performed. So what you see here is like activity is contingent upon the right to perform it. That right has to be possessed by the user. That right is recognized by an authority. The right is issued in the form of a credential that's held by the user. So the actor could be a drone, has the right to move this material, which is less than 10 pounds of non-flammable material, between the hospital and the distribution center, at this specific time of day. That's the activity. It has to basically present a credential from the FAA that's been issued to it that says that a drone of such and such class or an AI of such and such class can perform this activity on this drone. And you can apply the same thing to some sort of virtual character moving from point A to point B, or performing any sort of activity, including, say, can perform a transaction, or can exchange a currency, or can purchase or buy anything. This becomes important because one of the big fears around AI is that if it figures out how to buy property, it could purchase more, it could essentially design some sort of method for controlling land in a way that would give it sort of some sovereign capability. There may need to be laws that say that algorithms or things that are not recognized by some government or the United Nations or whomever is not allowed to do that, and therefore it would be constrained from doing that because it wouldn't have the authority or credential or effectively the right to perform that activity. HSTP is a query language. I'm going to kind of zip through this part, but essentially lets you do queries over ranges of space. So kind of like how we can query maps as opposed to querying file systems and say, let me show me all gas stations within Los Angeles. It can do this over multiple nested coordinates, meaning it can search lat-long elevation into an XYZ position. So you can see here, there's a little virtual sword at this XYZ position, but you may have started from some lat-long elevation exterior to that subdomain of that building. You can do this across dimensions, and you can do this across multiple sort of vectors, meaning that you can look at not just dimensions of space and time, but dimensions of, say, ownership, or range of gender, or range of happiness, or what have you. So all of this can essentially be sort of vectorized in such a way that then you can have consensus over certain definitions of conceptual or categorical ranges in space, which now are formatted in such a way that both humans and AIs can traverse those. So what you get out of this is sort of computable context, where you have now a complete and coherent digital model of the world that can accurately and holistically represent the spatial or physical dimensions, the semantic dimensions of meaning, the social dimensions of sort of values and ethics, and the systemic sort of nested dimensions of the interaction of lots of different interdependent components and all the relationships between them. And then this can apply to all kinds of things: IoT ecosystem governance, and the design of smart factories, and the connections across a global digital supply chain where you have an autonomic relay race between, ships and trucks and cars and drones all the way flying to your house that, at some point has no human involvement. Obviously, autonomous mobility of all kinds. All of the smart home activities and capabilities and controls and interoperability, which is a total nightmare right now in the smart home space, as well as rights and access to data, which would be conformant to the laws. So GDPR says, hey, look, these devices can use this data, but they cannot use them to profile users and then target them with ads or resell them to Facebook or someone else. That can be built into law that then is basically converted into HSML that then constrains the digital systems from those activities. This will apply then to things like, health data, HIPAA policy. And as we start to get into more and more biometric information and ingestibles, this becomes increasingly important that we have these levels of sort of governance and control to all of the devices that will be capturing that data and who we want a permission to access that. This applies all the way from everything from the smart cities, where you get this sort of shared context that is both a sort of human and machine understanding of people, places, and things. This extends into the enterprise space. It will apply to sort of, educational content, accreditation. Did someone perform the right activities? Did they learn the right things? Can they demonstrate that? Extends into all sort of concepts of objects and users and activities and assets inside of the idea of the metaverse. And this applies all the way up to scales around, planetary scale digital twins that are tracking, let's say, like the IoT devices. Imagine 100 billion IoT devices tracking carbon activities around the entire planet at every major factory, out of every major vehicle, out of your house, and then our ability to actually see that in a sort of holistic real-time way, and then do predictions and design incentives, even economic incentives around the moderation of that. Well, ultimately sort of this turns into this sort of global collaboration canvas, similar to the web today, but that actually extends into both our human experiences of virtual things and the activities of digital things or machines operating in the physical world. A handful of use cases. I'm just gonna skip over those and just kind of wrap up with what we want is the ability to have the sort of single internet of everything, the sort of network that extends into the spaces around us, upon which each of these different spaces become smart, powered by artificial intelligence that can understand human context, that is operating under devices that we have some margin and method of control over, that ensures that their activities are compliant with our policies and our laws and our values, and virtual experiences that take us, to places that we can only imagine, which will increasingly be generated by AI, and allow us to, search and traverse and navigate and interact and transact within them. So I think that's probably enough for today. Thank you.
Thank you so much for that presentation. What I always find interesting is, I'm in this space myself. I understand how you can go two routes. You can either build a very simple system and simplify the world into some very simple interoperable assumptions, and you can build systems out of that. Or you end up in the other direction. You could run into that clueless, and you start building, and you run into exponential intercomparability problems because you have to write adapters between everything all the time. And suddenly, when you want to build these big systems, they reach a level where you can't control them anymore. And so I think what's interesting in the work that you guys do at the Spatial Web Foundation is you really try to think this through somewhere in between the unmanageable and that effort that one can do when you build these simple connections. And so that I think is the really interesting part. And I'm so curious, when you reach the level of or let's form it as a question. When do you think you reach the point where this is something that could become a backbone for digital twins, for digital thread, for that world of intercompatibility?
Yeah, this year. So we're doing the D3 version of the Spatial Web specification now. That'll probably get submitted in September. It's been 5 years in the making. The last 2 years aggressively within the IEEE working group, 120 global participants and members, and of course everyone here is welcome to join and participate as well. You can get access to the document. Any and all feedback is very helpful. And so we are kind of at the point now where most all of the comments have come in and are being addressed. We're at the margins of issues now. So we're at the third full iteration of the document. And we expect to submit that in September to the IEEE Computer Society and the AI working group, which we're in. And a lot of this now has become even more increasingly important because the whole world has gone in a full panic around AI governance, right? And so this does address those issues because it fundamentally deals with data and how data is structured, data permissioning, and even sort of like, so let's say, knowledge representation and reasoning in a very explicit way. And so it's the exact opposite of our current approaches to AI, which are essentially, give it lots of big data, statistical, build a neural net. This is the opposite. It's explicitly modeling it in such a way. And then we can start to apply things like active inference AI agents, which is what we've been doing, that don't need any big data to train on, they're able to suddenly start performing completely coherent activities without having trained on literally anything. You just give them some priors and they're able to operate, and then they can adapt and learn in real time. So the timing on this, I think, is, we were the people sort of building the ark in a desert. I was like, they seem smart, but kind of crazy. All of a sudden now it's the opposite, is that the attention has really sort of shifted and people saying this is really critically needed. And, we can't really leave it up to free market commercial corporations or governments with like a patchwork quilt approach to this if we want to get the benefits of interoperability and sort of reliability around governance and explainability and interpretability and all that. So the timing is quite good. We feel like we're at the 90% mark here. And then the work we're doing at Verses has actually been developing solutions based on the proto versions of the standards. So it's not theoretical. We've deployed products and projects that are testing all of these components in very practical ways. There's always the question about scalability, but maybe the last thing I'll say about that is that our approach was to go back and look at first principles and look at nature and try to take a sort of biomimetic lens on this. So we studied mycorrhizal communication in mycelium in forests and said, well, what's happening here? Well, they've got an address for every single tree or plant as if it's a node. They have an ID that they know which ones they're communicating with. They have a ledger that they take fees for exchanging, glucose or different sort of different minerals from the system and exchanging those between the different parties. So you have glucose and carbon and phosphorus and nitrogen, et cetera. And these are the kinds of currencies of these systems. And then, of course, they enable, communication between them. There's even cybersecurity attached through these systems where, one tree is attacked by some bug and it sends out a signal through the network telling all the other trees, and then they start secreting something that will prevent the bugs from attacking them. So there's, we spent quite a bit of time really looking at trying to make sense of the fundamentals. And it turns out that networks are a preference of nature, and that the architectures are fairly simple, as you pointed out. Extending that into something where the real challenge, which is how do you properly model sort of human experience and human knowledge in a machine way, that becomes much more difficult. But we do think that we have got a handle on that now. So progress is going quite good, and we feel like we're kind of at the final phases of, I'd say the final phase of the first stage, which is just beginning.
So I think that the last I know about the IEEE group is you have quite an impressive list of participants of industry and organizations. And do you see any kind of, or like, what is the kind of interest there in general? Like, what are the centers that people are kind of huddling around that seems to be of interest, and what kind of application would you see from the participants that join?
Well, it's the purpose of the standards is to be very horizontal, and that there will likely become individual substandard groups that will emerge that might be more focused on specific industries. But the ones that have, where there are active participants and upon which, we see already a lot of demand for, kind of break out roughly into the global supply chain category. So everything from manufacturing, through the entire logistics and supply chain. This is the kind of the nervous system of the planet. And so there are a lot of big players in the manufacturing and distribution space. Autonomous vehicles and drones and robotics. So how the machines touch the real world is on kind of the other spectrum of that. Obviously, those two go together. There are a lot of participants interested in the applications to virtual worlds, metaverse, NFTs, organizational capabilities of virtual worlds. It's not like you can just set up a virtual world that is intended to be, let's say, an operating environment with an economy just because you're good at designing narratives for games. Like you actually have to structure some sort of a society, and so this will enable those kinds of tools. There are quite a few people in the AI, I would say AI or data and identity ethics space, very concerned around data authentication, credentials, human rights relative to the activities of machines, and then actual so like there are members from the World Bank and ministries of finance, and those looking at the role of digital currencies in the future. And one of the things about these about mycorrhizal networks, fungal networks in forests, is that they can do sort of like atomic swaps, what used to be called atomic swaps. So they can sort of convert from one chemical to another chemical, right? So, oh, you gave me this and I'll give you that. And they act as a kind of bank. In the spatial web, you can define each asset by its attributes and states. You could essentially enable something like every single object in the spatial web, which would be every object, is effectively an NFA, meaning it's a non-fungible asset, not a token. It's not a receipt representing the thing. It's essentially all of the ways you can describe the thing. What this does allow for is some sort of potential where you could just exchange anything for anything, because all the attributes or states or value of that thing could be defined in some way. So if parties agree on any form of value exchange, then the mechanism could just allow for swaps of anything. So you don't even necessarily need a currency to be a proxy. You could actually have sort of just real-time trades between things, because there would be mechanisms for valuing anything. Whether or not parties agree, that's a classic problem. We're not saying we're solving that problem. We're saying that the technology enables that kind of capability, which is quite fascinating.
The one question that come up in my mind is like, we learned from you so much about the spatial web and the infrastructure that you envision. Can you tell us a little bit about Verses and the applications that you prototype around this infrastructure?
Sure, yeah, I'd love to. I also got a few questions in the chat. Would you like me to do? I can go in any order you like.
Go for it.
Let's see, I'll just pick one. Big Rock Creative, hi. Since our data is unique and personal to each of us, it's like our digital DNA. What about the possibility of everyone getting an NFT of their digital DNA? Then we can use that NFT to log into a place, and we can lease out the NFT to companies to use that data. Yes. And then NFT equals authentication of ownership. So that is by design in the spatial web. And so spatial web ID is effectively by default non-fungible. The problem we have today with NFTs, let's say one challenge of NFTs today is that one, it's not the asset itself, and the NFT is usually quite a poverty of description, right? Essentially, it's a link to something that is the thing, or a reference to it, which is not linked. So you have a binding problem. And so what you want is to be able to have something like a digital twin where the binding is so obvious that like the level of detail on the definition of the thing, like the current state of Gabriel today will be different tomorrow, right? And so but some things will be consistent. So being able to have representations of objects, of activities, of users standardized is key. So the second problem with NFTs is that they only work on blockchain A, not B, and not B and not C. And so the blockchain has so many sort of scalability limitations, and the concept of an NFT has sort of a fundamental shortcoming. We saw this basically in the entire collapse of Web3 in the last 12 months, from, let's say, a sort of market perspective, in part because there was so much fraud and theft around NFTs that they weren't very secure. There wasn't a whole lot to trust there. So the concept, I think, is quite strong. The implementation is very poor. The limitations, whether you can get to soul-bound tokens or whatever, that's only going to work on Ethereum. You need interoperable methods for this, and interoperable methods for authentication and validation. And so it does solve that. Whether you want to have your identity to be bound to your biometric data, which I think people increasingly will. Not only will it act as your digital DNA, it will be your DNA that is being represented in a sort of zero knowledge proof way that becomes your major authentication. So whether that's your pupils, or whether it's, thumbprint or whatever sort of biometric, or a combination of a sort of multi-signature in different situations, walking into 7-Eleven, maybe they don't need anything. Walking into your favorite restaurant, maybe you want to give them access to, your profile of your latest dietary profile. I'm gluten-free again this week. Walking into, a government facility, maybe you need 5 different levels, and so it's not about sort of a single thing. It's about building on this essentially profile that is a reliable reflection of you. And so it does support that. And so it's a great concept. And I think it's really just down to how to do it well. The other question is that PON, P-O-N? Do you see an application of the accountability perspective in governance and physical development planning? Can you talk a bit more about applications for zoning, planning, permissions, and real estate approvals? Also, are there any new outlooks in Web3 for energy efficiency at the consumer level and demand side? Let me see if I understand the first question. Applications for zoning, planning, permissions. Okay, so when you think of real estate and you think of spatial domains, and you extrapolate that from, let's say, the World Wide Web, all domains have X number of pages. Those pages have their own sort of subdomain addresses. So you take a city and you say, well, there's X number of zones or zip codes or buildings or rooms within the building. All that can be sort of defined. And then in any category of domain relative to that, so you're talking about things like whether or not this is an industrial zone, whether or not harmful chemicals can be in this neighborhood and not in that neighborhood, whether or not cars, autonomous vehicles, let's say, could or could not drive there, whether drones can or cannot fly over certain areas like the airport or over kindergartens, or they can, but their cameras can't work. All of this sort of governance capabilities. When you think of the concept of a smart contract, now extend that concept into any sort of smart object, and then give the governance to whatever the hierarchy of governance is in any system. So in a geopolitical environment, that's going to be the geopolitical powers. In the virtual world, it's whoever set it up or whatever the policies are for that. But my point is that you can address all of those things, including what objects or information is available on a building. So construction or maintenance of a building, or like this is a classic problem in many cities where they're drilling or they're digging underground and they don't know what underground cables or gas lines are there, right? If we had a really good MRI scan of all the various sort of cables and lines inside cities, we'd be able to prevent a lot of accidents that have taken human lives out of that. And so the ability to properly model everything from the ground to the sky here in this sort of digital twin way is important. But then the permissioning of that, like there are literally laws and rules and contracts that say, like, the lines for T-Mobile and the lines for Verizon that are underground in, like, say, Market Street in San Francisco, that they're not allowed to be, one's not allowed to know where the other one is located. So you need to be able to, like, micro permission in the same way you can permission, who has read or write access to certain parts of a website. We're going to do that to spaces now and to objects in spaces and so on and so forth. So all that applies to zoning and planning and permissioning and real estate approvals and the whole process from the land all the way to the maintenance of the building that's on the land. Clearly, this can also apply to anything around energy traceability, energy monitoring, and energy incentives on both the consumer and the level and demand side, right? So you enable economies by enabling traceability, by enabling interoperability, you enable network effects and enable scalability by being explicit about how to define and represent things and people, places, things, and objects and activities in this very sort of formal way. You get governance because you can define what can or cannot go where, when, and how, and you have ways of credentialing those activities, especially for autonomous things that we won't control, right? Of whose control we don't, in order to gain the benefits of an autonomous system, we have to not control it. And so that's really the sort of the autonomy paradox that I think that we help address. So Valentine, I'm happy to jump to your question now, if you like. I think that was all that was in the chat.
I think in the interest of time, let's ask in the room. There are questions in the room here as well.
Yeah, happily.
Give them some space.
So can I speak from here, Jack?
Yeah, I think that's
Is it loud? Can you hear me? Is that fine?
I can hear you, yes.
Okay, cool. Just making sure, because we've had different microphone setups here. So super awesome talk. Thank you for sharing all that. Some of the questions that I had kind of relate to this idea of like leveraging just Web3, because Web3 has had some potential issues. One I think was mentioned was the idea of energy consumption, because if we are trying to model every asset in every part of the world in digital twin, it, the amount of like energy and data and storage requirements is kind of one of the potential concerns. There are ways to maybe optimize it, or have you like, are there ways to kind of tackle that? And that's a separate question. Like another issue that Web3 has had is it is technically decentralized, but if any groups become large enough or can be kind of bought out, like you can still fake governance in certain ways with enough buy-in. And I think like, how do you see it scaling to be large enough so that either just large governments can push out certain other ideas versus like large countries versus small ones? Like, is there a balance between that? So that's like two questions. So that's related to the Web3.
Yeah, thank you for the question. So if I understand, the first one is more about issues around scalability and energy efficiency of blockchains. And the second one was sort of power dynamics and government.
It's decentralized until you find different center points.
Yeah, okay. Let me, so this is my guess. I think, do you know what Flash is or was?
Yeah.
Flash websites. So before the iPhone came out, all of the coolest websites in the world were Flash. They were like this awesome, amazing animation. You know, Macromedia came out with it, and then Shockwave, and then became Flash. And it allowed you to just incredible sort of art and animation websites. It was super heavy. It took forever to load, but the interaction was very cool. And when the iPhone came out, when they were working on the iPhone, Steve was like, "This is killing the processor, and we're just gonna like ban it, like none, zero, Flash, no Flash on iPhones." And it was, you know, it was a limitation of the hardware. I think they would have liked to have accommodated it, but it just made it impossible. So when they designed Safari, it just kicked everything, killed all Flash sites. And most probably was 30% of the web. I don't know, it's probably like 100 million sites. I don't know. I'd actually be interested to go look at. So later HTML5 came out, and it didn't do the exact same thing that Flash did, but it did enough to where like you could do cool animations, and everyone's like, yeah, that's fine. Like everyone cried over Flash for like a year, and then that was it. It was toast. And my guess is that blockchains in general are Flash for, let's say, governance, or Flash for digital economics. They are too heavy to actually scale. And so they will likely not succeed. Bitcoin may or may not do its own thing. It's even now, it's kind of a, it's very different than what it was designed for. So that's my guess, is that blockchains will not scale. The energy problem will not be solved. By the way, there's a similar problem with quantum today. And so quantum's kind of like supercomputer of yesteryear. Here's my caveat. AIs are figuring out things that no one could figure out before. Maybe it figures out a new kind of way of doing distributed ledgers that is more of a direct lineage of blockchain, meaning that there's an append ledger. Although personally, I don't have a lot of faith in that approach. We have some, like the idea of creating sort of the digital scarcity as a way of proving trust is maybe not the ideal model because of the entropic cost, right? So that's my first portion of that. Maybe there's a road out of the jungle, but I'm not very optimistic about it. I do think that's something that takes all of the philosophy behind it, distributed, decentralized, peer-to-peer, is going to like emerge, but I don't know what shape. You look at things like Holochain and distributed hash tables, and there are tons of other things that are much more lightweight that adopt some of those same principles, but not in the same structure. I think that those are more likely to evolve. Second question, I believe, was how do we prevent centralized control from dominating? Okay, so 2 points. Number one, there is a tendency to look at things through the lens of decentralized versus centralized as like binary, and then tend to go like distributed things are good and centralized things are bad. And in reality, if you look at nature prefers a hybrid approach. And so you often get hubs and spokes. Like just look at a forest. You get patches where there's nothing. That's where there's no fungus actually connecting the trees. There are parent trees and then children trees that create entire ecosystems. So you get a lot of both centralized and decentralized systems that are part of larger collective networks that are overall largely distributed. But hubs end up serving a real specific function in any network. And so I think that you'll still have that. Then the question becomes, can governments use this to basically become more totalitarian or more authoritarian, right? And the answer is yes. And the reason for that is that there is no authority on the planet that would be able to grant the right to say that that North Korea can or cannot do something a certain way. And since the UN is just a group of different nations that have a perspective on something but no enforcement power, I mean, we can't even in the case of conflict like the Ukraine versus Russia, they're essentially saying the border is X, the border is Y. You are ours, and they're saying no, we're our own. The UN can't do anything but say like we disagree, or we're going to. The United States can say we're going to sanction, but there is no actual planet scale authority. So this begs the question: if we end up in a society that is largely driven by technology, where you have wildly powerful autonomic capabilities powered by more or less what will be AGI for everybody, not like one massive AGI. I don't think that's going to happen. It's going to be distributed like smartphones and networks of these things working together. Then you drop in something like breakthroughs in fusion, which we just saw. Like you are on the road, not to a road of sort of poverty, but a road of perhaps abundance, of cheap energy and distributed intelligence everywhere. The question becomes, if you end up in an abundant society within 50 years or 100 years or 150 years, what does the role and function of so-called governance at that point? And so the larger philosophical question is, what happens if there's an escape velocity for civilizational abundance, and we've been going towards it, but haven't been able to break it? All of a sudden you crack through, and then it doesn't require very much effort at all. So it's impossible, easy. And so that's my prediction, is that we're headed towards some sort of escape velocity around physical and informational abundance, predicated by technology. And just looking at the rate of what's happening with AI currently, this doesn't seem like 100 years off. And so I think that the larger question is, what happens to economics, capital E? What happens to government, capital G, if in fact we cross over into that kind of an age? And
because the question there is kind of like, when you do have this abundance, but it's still semi-centralized or semi-distributed, where does the abundance go? Because there are plenty of ideas that us as a nation, even just in the US, like we have more than enough resources for everybody to be generally well off, but they're not equally distributed evenly. Whereas like a similar issue could come up where it's like we get an infinite number of abundance while still creating artificial digital scarcity. Is there any concern that something like that could be a way to maintain the same old status quo while still certain individual or small groups get the benefits?
Yes. Yeah. Unfortunately, we don't have a specific proposal for solving the human condition problem, but that's because it falls outside the range of what we think it's appropriate for us to be in charge of. Now, we have an opinion about it, and the Spatial Web Foundation, like the standards are let's say, unopinionated or fairly neutral. The Spatial Web Foundation is opinionated. You know, we do not support those types of activities. However, we don't want to grant ourselves the power to control that, because now all of a sudden we're the authoritarian. So we've purposefully like giving up that power in the process in order to let the game play out. We will be vocal advocates for what we consider to be things that are largely, you know, human-centered, user-centric, and that stem from, you know, more life, not less, and looking for sort of homeostasis at a planetary scale. That being said, I do think that there is a sort of escape velocity point where like having more abundance doesn't mean anything anymore. Like, why are you preventing someone else from having it? You have more than you can, like, and today's example doesn't quite sell because there's still an economic system that requires you to work, right? And so if there's one that doesn't require you to work, and then you have two options, you have, you know, nanotech and fusion makes it so you can just, you know, build a diamond house in the middle of the desert for like 10 cents, or the dematerialization is a function of virtual experiences where you can have an experience. So there's no poverty of experience. You'd still need, you know, the ability to like function as a biological entity or whatever. So in both cases, it seems like we are on a collision course to some form of experiential and material abundance. And so then the question really becomes, do the survival-based concerns that are behind, I mean, just think of the word economy. That's an example, how to be economic, or governance, which literally just means like managing the economy. You know, it appears like we may be at some other sort of threshold point here within a generation or two. And you know, my challenge to you guys would be, what does that look like? And what do you see that being? Because we don't have any good stories of that outside of maybe Star Trek, who skips over how the hell that happened and just goes to the part where we're traveling around the universe with no money, nothing costs any money, and everyone has what their needs are met. So I don't think we have any really good stories about this. And so it seems absurd, and all previous utopian narratives have basically gone dystopic. So how do we envision if we can provide the technical means for such a thing, us and yourselves and others, and that seems increasingly likely, where do we want to go? Where do we want to aim this? And who do we want to be when we get there?
Joe has a question, and then this is the last question, then we run overtime, way overtime.
No problem.
I love your optimism. Actually, we have Neil Stevenson coming next week, so I think this is a great build up to having Neil on board too. I'm going to ask kind of an orthogonal question, but it's a little bit related, right? We talked about Flash, good example of code going obsolete. We talked about wrappers. We build, in the old days, we had to build our own IoT standards because they didn't exist just to do what we want to do here at the Media Lab. Right. It's great we're coming to this world where it's happening with all of its you know, gnarly parts. It is coming together. But you kind of wonder how much the AIs will do, to go back to that issue. Right? Are they going to generate the wrappers? Because they can, you know, basically emulate or design the code and interoperate these things. And even obsolete code, it doesn't have to be obsolete anymore, because you can emulate, read the manuals, emulate the code with run it. So Flash, it could come back to life in a weird way.
True.
And then of course, that gets to the Colossus style nightmare, which you kind of talked about a little bit here and there. How can you possibly unplug this thing if it goes bad? Or is there a solution? This is going to control everything. It's going to be inherent in all the glue that makes this work.
So first of all, love the shirt.
Thank you.
Secondly, the things that we're playing with over, you know, Verses right now, Carl Friston, who's largely considered, you know, sort of top neuroscientist in the planet, joined us as our chief scientist. And so I've got about almost 20 AI, you know, PhDs that are all specialized in active inference. So they're like not part of the deep learning camp at all. They're on the entire other side of it. It was a bit of a match made in heaven, because we were coming up with this explicit knowledge modeling language, let's say for AI, just to keep it simple. The problem active inference has, I don't know if you're familiar or not, is that, you know, you need to basically model its priors, and then it's inferring, it's just like cybernetics mostly, like it's trying to basically determine a probabilistic likelihood of its model matching whatever the next action is in the world, in which case then it will try to seek information to double check and or then test it like we do by trying to do something in the world and see if it works. You either update the world or you update the model, and you're just trying to keep this coherence game going, right? So instead of sort of a backwards looking AI that's like, give me all the statistics and then I'll try to guess what happens next based on whatever your input is, you've got something that's trying to infer what's happening next all the time, and it's basically self-improving. So a lot of the biggest concerns that people have around AI that I would argue that even with Auto GPT and the rest aren't really happening. They're just kind of weird little mirages, although it's quite potentially useful or potentially capable. There's no self there to, because there's no internal model. So, you know, it can't really, there is no path to AGI from that. And you can't get to perspective, multi-perspective sharing, right? Like me thinking, what does Valentine think about you? Like that requires all this modeling. So the work that we did turns out that set it up so that you could now automatically model digital twins, environments, activities, conditions, policies, values, whatever, as the priors. And these guys were all just writing priors by hand. So there was no scalable road for active inference, which is why everyone ran towards the deep learning pond. Because I mean, look, it didn't work, and then now it's working. So yes, I do think that it will be able to write the wrappers. Yes, I do think that, I think it's going to be able to do whatever. I honestly do now. And we're seeing examples where we can just bootstrap the thing and be like, go find me an apple. And it never knew what an apple was. And then it'll basically download, you know, an HSML model about Apple. It's got a digital twin of the room. It knows where like a person's located who asked it. It goes and searches using computer vision to try to figure out, oh, that there's an apple. It matches all the attributes of what an apple is. The person moves. We have another camera as another active inference agent that says, oh, I no longer see that person. They're somewhere else in the room. Agent one, the little robot, then goes, oh, well, let me go find them because I know they're not in the kitchen now. They sort of subscribe to the movement of a user, and then goes and finds them and gives them the apple. And like there was no machine learning really involved in the whole process. And so when you get this sort of, you know, it's kind of like that Matrix moment, like, you know, I know Kung Fu. So just download whatever it needs in that environment, but you want to be able to control that. And so in that domain, in that facility, yes, it has the right to download that information. And in another situation or context, or if it was another robot or whatever, then it would be prevented from doing that. And then what was part two of your question? Oh,
They're kind of mingled. I mean, if AI is all about, it just defines the interconnections, right? At a certain point, if it ever turns bad, how do you unplug, right? That's always
the problem. So the unplug problem. So the reason, this is a great question. So the reason we designed the thing with the hierarchical domains is that parent domains have the right to control subdomains, just like they basically do in the real world. And so that means that policies and laws can be written under which a kill switch would be legitimately implementable. So X number of, you know, either a human actor or an algorithm takes over 1,000 drones in the middle of the city in the afternoon, starts flying them into buildings. Like there's got to be the right to hit the switch. And so we're not saying under what conditions that is the democratic thing to do, whether it's the right thing to do, who should or shouldn't be, you know, be able to do it. But the ability to do it is built in. There's one last thing, which is I believe this prevents the Skynet problem. Because if you think of this sort of through the lens of NFTs, but again, think of it as non-fungible assets with their own IDs, and AI is only, let's just say like a very smart AI is still only able to access, you know, the big fear in every AI story is it's not like the one AI that is a robot that like takes over the world, right? Like Galactus or something. It gets into the network. And the minute it gets into the network, now it can get in access anything, all data, all devices, and money, and start, you know. So what you can't trust the current internet or web to be a prevention for this. So you have to basically build a new ID and address, you know, and keys for that. In this case, the entire spatial web architecture is permissioned. And so it's a zero trust architecture that assumes that every action requires the right to basically access the data or the device. And you basically have to have the credential to do it. So it's kind of like onion a bit like onion cryptography, right? Where you've got like, oh, you got through one layer, well, we rotated the whole thing, and now you got to get to the next layer, and it's quite you know, people always suggest that that's quantum preventative. We'll have to see. But I think what this does is it makes it so like it's all locks and every door is closed. So yeah, maybe you get into one system, but you can't get into the next one, or it's equally as hard. So the idea that it's like in the web and now we're all screwed, you got to block this. And this is why you, in our opinion, you need to basically make all critical systems, update them so that every call, you know, isn't through the internet or through the web. And then you're going to have to basically certify and ID AIs. And we've been doing this project with the European Commission. We're on AI-powered drones in Europe, where we're translating all the laws in 5 different countries into something that then essentially a governance AI gets a request from the AI powering the drone saying, I need to fly between here and there. What are the rules or the laws? Like as if it were like a air traffic control. And it tells it what it is, and then it gets its credential, and then it can proceed down the path. The only other thing you'd have to build in is like who has the right to kill, you know, to down it or prevent that, you know, the sort of the kill switch move. But all of that is, we did at least conceive of that. It is supported. And then there are questions around the ethics of implementation. But the short answer is yes. This was one of my big fears when I realized you could essentially make computable space, that you could have AIs that could do anything. and how could we govern that? So the minute we got to interoperable everything, then the next problem was governing everything. And that's what we spent the last 4 years really working on.
There's probably also the interesting question of, once you make all that data accessible, you know, like once you really dig into all of those points of your vision, you know, build digital twins of everything. There's so much data that no human ever will be able to make sense of it, but AI can. And so that's the moment where you have the power dynamic gets a little bit in the interesting territory.
Yeah, what you're talking about is fault tolerant computing, where you've got different layers that don't necessarily work in collusion. So they're all basically working as cross checks.
Yeah, and these this is like where the real implementation work will need to come in, and where we move past theory to like what works and what doesn't work. The cool thing though is that you could build some pretty sophisticated simulations of this first, and then test it out before deploying because of its coherency. And one way to think about this is like you're kind of rebuilding the world for AIs, like the human world of knowledge and experience for AIs, that they can then operate in our world. The one saving grace that I'll just close with is that I believe this to be like an entirely natural phenomena, and that if you think of like the autonomic nervous system today, like 90% of what all of us are doing right now, we're not doing at all. Right? It's all being handled completely by a bunch of little autonomous agents from red blood cells to entire organs that are doing absolutely fantastic work in complete, you know, harmony and coordination. And if you can kind of extend that to the planet, and you can see many of the same elements sort of forming here and converging, then that's what I think ends up happening is you get this sort of autonomic planetary scale system, and we all get autonomic life systems, and our AIs are doing that. So it's, you got to solve that knowledge representation and reasoning problem. You don't want to do it in a way that's just basically feed it with the power of a small sun and all the data in the world. You want it to learn and basically improve and adapt and adjust that in real time. So that's where we've been aiming. And that's where I find, you know, that's where I take solace that evolution didn't break along the way here. And it does require us to sort of intelligently navigate through this, but I'm more optimistic than not.
That's great.
Wonderful. Gabriel, it was a pleasure to have you in the class and
Thank you.
learn from you.
My pleasure. Yeah, absolutely. This is wonderful. And Valentin, you're doing such amazing work. You know, I've been a big fan for a while. And I think it might be cool to set up a follow-up and show you guys kind of the active inference agent stuff we're doing, the demo I just mentioned with HSML, and see if there's some cool, like something we can collaborate on, or some way we can get you guys involved so you get early access to like the stack and can start playing with it as well. If you're interested, be happy to do a follow-up, you know, maybe next month and have the team come on, walk you guys through the demo, and then look for some, you know, intersections down the road here later this year.
That'd be great.
Cool. Okay.
Thank you.
Thank you, Gabriel.
Thank you. Feel free to ping me. I'm on Twitter, and I'm at Gabriel at Verses.ai. If you guys have any follow-up questions, really appreciate the opportunity, and have a wonderful rest of your week.